Today, geometry, we are continuing with CO12, which we are introduced to what are called if-then statements, which is saying that if you know something is true, then this is what can be concluded. And that is the framework of a logical argument. You're taking what you know and using it to conclude new information. Okay, it's not snack time right now. You got to put that away. Right? So a conditional statement, if this, then that. It's called a conditional statement because this if is a condition, right? If this condition is true, then we can conclude this. Okay? That is kind of the starting of an argument. The rest of these are all different combinations of what we have here. Notice the position of this and that. The converse is if we reverse this. If that, then this. We say, is the conclusion that we made, if that's true, can we conclude the original hypothesis? And this is going to make a lot more sense once we kind of start actually working with specific examples. And I actually found a really nice PowerPoint that I made like 8 years ago that they used to illustrate this point. I wish that guy was still sitting here. It's fantastic stuff. But what I want you to focus on right now is just the position of the this and the that. Okay? The inverse of a conditional statement. If not this, then not that. If we negate the hypothesis, is the conclusion also negated? If not this, then not that. Okay? Then finally, the contrapositive.
What?
If not that, then not this. If we negate and flip the hypothesis and conclusion, what are we left with here? Okay? So let's focus on the position of this and that. And we're actually going to fill in different phrases for the this and the that coming forward with the help of a PowerPoint. And that is going to help you understand exactly what's going on here. For right now, just focus on the position of this and that. Yeah?
So would this be assuming for all of them that this is one thing and that is a different thing?
Yes.
Okay.
This is the hypothesis. That is the conclusion. Okay? I mean, an example of this would be like, if you chew gum in the classroom, then you will get picked. Right? The condition is, if this happens, then this is the result.
Only if you get caught.
Okay? Correct. If you don't clean your room, then you will get grounded. Maybe for some of you that might be a rule. If you fail a PO, then you need to retake it, right? There's an if-then statement as well. So it's taking something and concluding something else. If this happens, then this will be the result. A biconditional statement, which we're not going to talk about in this objective, but we will later on, is if and only if. Okay? An example of that would be like a quadrilateral is a square if and only if it has 4 right angles and all sides are congruent. Okay, there's something that is a specific condition for that. Have I confused anyone so far? Hopefully all of you. Okay, yes. All right, but let's take a look at what it's actually saying here. And again, we're going to use the aid of my fantastic PowerPoint to slideshow, view show from beginning. Let's go. Okay? Yes, Luca. Noon. If this, then that. There's your conditional statement. We have that written down on our page already. Okay? The converse, just kind of a review. If that, then this. What? 1. Sorry, I said noon. 1. The inverse, if not this, then not that. So the this and the that have been negated. And the contrapositive, if not that, then not this. Again, just reviewing what those notes were that you wrote down earlier. So, snow is falling, it is chilly. What is the conditional statement that we can write for this? What's our this? What is our that? What is our hypothesis? What is our conclusion? Ari, what do you think? What?
I don't think I got it.
You want to take a guess? The worst you can be is wrong. No, so don't worry about this right now, okay? Just in this statement, snow is falling, it is chilly. What is our this? What is our that? What do we notice? What do we observe? What's our hypothesis? What can we conclude? Evelyn?
If that, then this.
No.
Please,
That's not what he's asking.
How do you do it?
If snow is falling.
Okay. If snow is falling, then it is chilly. This right, whoa, that is really not calibrated very well at all. Oh my goodness. Woo! I'm not gonna write this. So the this here is snow is falling, right? If you look outside and you see snow is falling, you can conclude it is chilly. Right? Because can snow fall when it's 60 degrees and sunny and warm? No, it cannot, right? Now, you might have different definitions of what chilly is, right? Some of you wear shorts all year round regardless of what the temperature is. But generally, we can all agree that if it's snowing, it is chilly. Okay? Yes?
How is this math?
Again, what I said yesterday, don't focus on this in the math sense. This is a logical thing. We're starting not mathy because you've all experienced this. We live in Minnesota. You look outside, you can kind of tell the weather based on what's going on. Okay, you've done this before. So don't focus on the math right now. Okay? Is this true? If snow is falling, then it is chilly. That is true. Okay? Our conditional statement is true. What is our converse statement now?
Where are we looking?
On the bottom of your page where it says if snow is falling, then it is chilly.
It's in the middle. Yeah, where are we writing this stuff? Like the
So you should have lines next to conditional, and you're writing this on the conditional statement line,
Oh.
I got the next.
and then you're circling true because this is a true statement. What would our converse be? So we've already identified our this is snow is falling, our that is it is chilly. Our converse flips those around. What will our converse statement be? James?
If it is chilly, then snow is falling.
Well, look at those graphics. Okay? If it is chilly, then snow is falling. Is that true or false? That is false.
I mean, it could be true.
Okay?
Yeah, but like it could just be cloudy.
But just because it's chilly doesn't mean that snow's falling. Right? There are plenty of days during the winter where it's chilly without snow falling. Okay? So we'll get back to there. Our inverse. We negate the this, negate the that. What would the inverse statement be here? Aiden?
If it's not chilly, then it's not going to snow.
No, it's opposite.
It's the opposite of that, right? Remember, our this is snow is falling. Our that is chilly. So the inverse, if not this, here you go.
If snow is not falling, it's not chilly.
If it's
Oh,
not
brother.
snowing.
It's false.
I said snowing, yes! Oh. Wait, what's snow?
What is
Today.
this?
I didn't preview the whole thing before I put it.
Today.
Oh no.
This is 2016 Schultz right here. Oh, good. Okay. The inverse, if not this, then not that, right? If our original this was snow is falling, the negation of that, the not this, would be snow is not falling. If the original that is it is chilly, the negation of that, the not that, would be it is not chilly. Is that true or false? If snow is not falling, it is not chilly. That is false. Okay? That is false. How about the contrapositive? If not that, then not this. You flip and negate. What's that going to look like? Mario?
If it is not chilly, then snow is not falling.
What is occurring?
Oh my.
What in the world?
It's like a blizzard.
Am I having a seizure?
This.
I
I don't think
can't
we
accept
should,
this.
I don't think we
You're
should be
glad
using.
the guy left.
What's that?
You're glad the guy left.
I mean, this shows
Pretty
my
high class.
my technology side. Oh, there we go. If it is not chilly, snow is not falling. Is that true or false?
False.
Yeah. If it's not chilly, snow can be falling. And again, your definition of chilly might be different, and that's where there'd be some wiggle room there, right? But if it's not chilly outside, snow can't be falling. There's a certain weather condition that must be true. Okay?
Oh, it's 2 pages.
So,
First time this week.
Here is the actual application of the this and that conditional statement. Okay? If this is true, then we can conclude that. And if your conditional statement is true, if it's actually a true statement, it should follow this pattern of true, false, false, true, going through the converse, the inverse, and the contrapositive. Okay? Let's look at another example. This time I don't think I put the, here's the mathy thing for you. Okay? An angle that measures 34 degrees is an acute angle. What's our what's our this, what's our that? What's the conditional statement?
If an angle measures to 34 degrees, then it is acute.
Okay, and is that true?
Yeah.
If an angle measures 34 degrees, money,
Oh, that scared me.
if an angle measures 34 degrees, then it's acute angle. Is that true or false? It is true. There is our conditional statement. Okay? What would the converse be? If that, then this. What would the converse be? Luca.
If the angle is acute, then it's 34 degrees.
Okay? If an angle is an acute angle, then it measures 34 degrees. Is that true?
False. Because it can be more.
That's false. If an angle is an acute angle, it could measure 40 degrees, or 89 degrees, or 2 degrees, or 17 degrees. The fact that we use then it measures is a specific thing. Okay? This is a false statement. Even though a 34-degree angle is an acute angle, we can't flip that around. If an angle is acute, it's not necessarily exactly 34 degrees. What's the inverse?
If not,
Aiden?
If an angle is not 34 degrees, it is not acute.
Oh, my.
Nailed it. Okay? If it does not measure 34 degrees, it is not an acute angle. Is that true or false? False. Right? An angle that doesn't measure 34 degrees could be 45 degrees. Is it still acute? Yes. Okay? So far, we are seeing this is still following this true, false, false. Next one should be true in theory. What's the contrapositive? If it's not an acute angle, it does not measure 34 degrees.
Oh, my gosh. Never do PowerPoint again. Never do PowerPoint again.
What?
I'm reporting you.
I can't hear you. Oh, golly.
Can you mute this?
Okay. If an angle is not an acute angle, it does not measure 34 degrees. Is that true or false?
True.
True. If it's not acute, it can't have an acute angle measurement. It's not 34 degrees. Okay? Yeah.
I reckon she feels when the comments do.
Well, she hasn't yet, so I think we're okay.
I think we should do another one.
I think we should.
I don't think they're
max
doing
out
that.
the
I think
volume.
that's-
I think we max out the volume.
That might be the end.
Do it right back.
Yeah, that's the end of the PowerPoint there. Okay. So your job is. Whoops, didn't mean to do that. Your job is to come up with your own. Okay. Come up with a conditional statement that is true. If this, then that, and then write out your converse, inverse, and contrapositive. It does not have to be math related. Okay, it can be anything. My first one was about the weather. Second one was about that. Okay? You can write it about whatever you want. And this is gonna be homework for tomorrow. Okay?
So what if I'm at school, then I'm learning?
No,
Not always.
not always.
Well, test it. Does it fall? Would that follow as you run through the other ones, that true, false, false, true pattern?
Does it have to be that?
Yes. It needs to follow the true, false, false, true
Oh,
So
pattern.
that's how you can like check if something is true or not just by running it through.
Alright. That's our math.
Don't forget to like and subscribe.